Hello, everyone. Welcome to Constellation, our occasional webcast where we talk to the stars in and around the Qualcomm ecosystem, both our partners and people within Qualcomm who are making a difference for developers. I'm Sascha Segan with Qualcomm PR, and I am absolutely thrilled here to have Zach, Alex, and Alan all from the Qualcomm AI Hub team to talk about our new product, Genie X. And before we get to explaining what Genie X is and where these folks come from, I wanted to say that I am so excited for this product because for years now, I have been promoting running AI locally. I think it is hugely important to run AI locally. And I think that local execution has to be a much bigger part of the AI landscape going forward. If we look at the accessibility, if we look at the power efficiency, if we look at the flexibility of running AI actually on your devices as opposed to in the cloud, very important, absolutely has its place, is going to be, probably most of AI going forward. But running more AI locally is going to dramatically improve the efficiency of AI, the flexibility of AI, the responsiveness of AI, and these guys are here to show how to do it on Snapdragon. So thank you guys so much for coming to speak with me. And first of all, I was hoping that you could introduce yourselves because you guys were a startup, right? What was your startup, and how did you end up at Qualcomm?
Yeah, so maybe we can get started. Hi everyone, I'm Alex, and previously I was the founder and CEO of NextAI. So NextAI is a company dedicated on-device AI model research and deployment. We especially study how to, deploy those models easier for developers, and at the same time maintain a high accuracy and a high performance. Zach?
Hey everyone, I'm Zach. I was co-founder and CTO at Nexa AI, and now our previous product, Next SDK, is now GenieX, and we look forward to sharing you more details how GenieX work.
Yeah, and I'm
And
Alan. I used to lead product at Next AI, and we are like you, Sasha. We are very excited about bringing AI on device, running it on every single intelligent devices, and basically build that agentic experience across all the devices. That's our has been our mission, and very excited for this Genie X launch and talk more about it.
Yeah, so why did you guys join Qualcomm specifically? I mean, you were a startup, you could have exited in various ways. What is it about Qualcomm that made you feel, oh, we're going to fit in here, we can do good work here?
I think the biggest incentive here is sort of like on-device AI is our mission, and we joined Qualcomm because we saw it as the best place to scale our original mission. As a startup, we could move fast, build new on-device AI technology, but bring it to hundreds of millions of devices requires deep integration across models, software, silicon, and OEM products. And we think Qualcomm has a mature platform for it. So our goal is to reduce the friction between having a good model and actually shipping it. Developers shouldn't need to become hardware experts to achieve great on-device performance. We believe with our software and existing Qualcomm ecosystem, we can achieve our mission.
And you're talking about all across the ecosystem too, right? Not just one product category, but all the different kinds of silicon we do, right?
Yes.
That's pretty amazing. And for the viewers, I want everyone to be aware of how we've been talking about this whole milliwatts to kilowatts situation over the past few weeks and months. That when we're talking at Qualcomm, we're talking about single board computers, we're talking about robotics, we're talking about home home security cameras. We're talking about cars. We're talking about smartphones, PCs, all sorts of different devices. It's not one product category. It's more product categories than pretty much any other company I can think of has. So guys, relatively briefly, relatively clearly, what is GenieX? And if there are developers on this stream, what are they going to be able to do with it? Alan, you're the product guy. This is I think this is for you to pitch.
Yes, sounds good. Feel free to chime in later, Alex and Zach. So GenieX is an open source runtime that enables any developer to run frontier LLMs or VLMs on Qualcomm devices across NPU, GPU, and CPU, just within a few lines of code.
That's great. And so that is much less complex than the previous SDKs that we had for doing this sort of stuff, right?
Yes.
Yes. An example is that, if you now have a Snapdragon laptop, you can basically finish all the setup in 1 minute, and then you can run a model in our NPU within 1 minute.
Yeah, and I in fact have been doing that on my Asus A16, and these guys know because I've been bombarding them with performance numbers from various AI models. It's so easy. It's so easy. Like, I'm barely a developer. It's so easy. So how are people using on-device models now especially in phone and PC app? Okay, wait. I'm going to start first by GenieX. This version of GenieX only targets specific chipsets, right? Like, you're starting somewhere. What chipsets are you starting with?
For the existing GenieX, it has already supported various chipsets, like across phone, laptop, IoT, and automotive. But as you mentioned, like there may be some other chipsets we haven't covered, but we are actively expanding our coverage.
So how are on-device models being used now in phone and PC applications? Obviously, like, GenieX is going to make it so that people are able to use them much more. But what are some of the ways developers are starting to use them now on PCs and phones?
Yeah, good question. So actually, on-device AI is already widely used, although like much of them is not that visible at this time. So on phones and PCs, it already powers cameras, speech recognition, translation, image editing. For example, when we do the live stream, you see the camera is presenting you in a better way, and there is also something like the object detection and tracking your position relatively to the camera. That's usually due to the on-device AI. And there is also some new capabilities such as local search. Those these days, like the new OEM and operating system, they are powering the local language search across all your files. That's also part of on-device AI. And we also see local models supporting the coding, agentic coding. And of course, there is content creations as well. For example, we see software from Adobe. Now you can generate the new images and totally from the local AI model. So we think the future is likely, as you said, hybrid. The on-device will handle tasks requiring privacy, low latency, and personalization for offline access, while cloud still handles heavier workloads.
Great. Now we're starting to get some questions in, and they're pretty good questions. So I'm going to start interpolating the audience questions in with my own questions. And I think the first one from Faluda on Discord actually shows a kind of thinking that people need to have about GenieX, which is so they started playing with GenieX, and of course, they tried to force compute unit GPU, which is not what you should be doing with GenieX in my mind, because they don't know how the hybrid the hybrid execution works. And so maybe you can explain, when you're executing a model with GenieX in its default mode, how does the hybrid execution work? Where is it distributing the work to? So that developers, probably should not be forcing it to a certain compute unit.
Yeah, I can pick up this question. So by default, GenieX using the hybrid mode, and it will leverage all your CPU, GPU, and NPU to achieve the best decoding and prefilling speed. However, we actually provide an argument called compute. So when you run GenieX -- compute and specify NPU there, so it will always offload purely on NPU.
And then, so now if you say hybrid is distributing, does that mean that prefill and decode might be on different compute units? Because the NPU, like we know, the NPU is terrific at prefill, but for instance, the CPU may be better at decode.
At this moment, we mainly offload the operators into different compute units. As you know, for LLM inference, there are many different operators for the computation. And so heterogeneous computing, that is something we are considering about.
Okay, great. And now, okay, so going to the next question, that actually goes to another really interesting question about using GenieX, which is the models that people need to use for GenieX. And can you talk about, the difference between AMET models and GGML models when it comes to using GenieX, why you might want to use one rather than the other, the advantages and disadvantages between AMET and GGML, GGUF?
Sure, I can take this question. So actually, GenieX supports two backends, as you mentioned. One is through Quart, and the quantization is by AMET. The other path is through Llama CPP, and the model is in GGML format. And usually, developers can choose the Llama CPP for GGML models because it has day zero model support. So when the new model launches, you can have a taste of its hexagon NPU performance there. And for the Quart, it usually delivers the best performance after the offline compilation. I can give you a quick example. So if you look at our AI Hub models, the Q134B model, the Quart pass, the prefill can achieve more than 2,000 tokens per second and almost 40 tokens per second decode. That's quite amazing. But Llama CP can also achieve roughly 500 prefilling speed and 14 token decoding speed. So usually for new models, you can take a try on Llama CPP, especially for those like Gamma or Q1 3.5. And the Quart model usually has better performance optimization through offline compilation, graph optimization.
And if people want, if people want more models or want specific models done through Quart, done as AMET models, is there a way for them to request that? Can they do that themselves? How do we get, like, if someone wants to work with a specific model and then wants that as AMET and it's not in the AMET library right now, how do they get there? Guys, Zach, Alan, one of you guys want to take this?
Yeah, so I can take this question. So
okay, great.
I think the amazing part of GenieX is that it's fully open source, and inside the repos, we actually have a lot of efforts to there are a lot of like cloud code skills, so that if you are a developer, for sure, you can leverage what we have done there, and you can access all of our code so that you can even onboard a new models, participate in us and supporting new model. If you are not a developer, you can freely file an issue in our GenieX GitHub repo, and we'll see it. Maybe another developers outside of Qualcomm, they can even help, contribute this model so that everyone can use it. So this is also like one part I'm personally very excited about it, because you see like our team is now have huge conviction in open sourcing. And I can tell you like for GenieX, all of the things are open source. Yeah.
So it's all happening out in the open on GitHub. If people want something, they can file an issue, and hopefully you guys and the community will come together on that.
Yes.
Great, great. Now, also, another thing Faluda was asking that I noticed about the AMAT models is that all the AMAT models are only 4K context. And is this a limit of AMAT, or is there a possibility of greater context on those models? Or should developers looking for long context be working mostly with the Llama CPP backend? What's your recommendation if a developer wants performance, but they're trying to get a long context situation?
Sure, that's a great question. So firstly, AMAT is not restricted for 4K context. It's because when compilation by default, it exports the model with 4K context length. So if you use you use AI Hub Workbench and convert a model yourself, you can specify different context lengths. Secondly, Llama CPP has some flexibility because when you run a GGF model, that is a parameter in the runtime. So you can specify context length 4K, 16K when you run the model. So yeah, so for simplicity, you can use the Llama CPP plugin to run longer context lengths. However, we are working on this on our roadmap to support longer context lengths or support arbitrary context lengths through like sliding window and other techniques.
Great. Yeah, I feel like once people see the prefill speeds on the NPU with the AI Hub models, it's really hard to go back to anything else because the prefill speeds are so amazing, and it really it invites questions about wanting to run longer context, because you're like, oh my goodness, I've got, I'm getting thousands of tokens per second prefill on this NPU on my laptop. Can I do this with 16K? Can I do this with 65K? So it's good to hear that there's a path to do that now, and the path is going to become easier. So I think that so I do think that there's a big disconnect in the open source developer world right now between the smaller models, which are popular on device, and the public discourse, which is often about running the largest model that your hardware can possibly support. Like, I don't know if you guys are watch Local Llama Reddit, but often that is just some, guys swinging around their ability to run 700 billion parameter models or whatever. How do we get more respect for small models? How do we get people understanding more clearly what small models can do in their lives?
Yeah, I think that's a good question. These days, like, people are developing larger and larger model with more generalized capability. But if you look at this problem from the perspective of users, they don't experience like parameter counts. They experience speed, reliability, battery life, privacy, and whether the product actually works. So one of the our previous partner, they are developing like a small model, and they are partnering with another company, and we see that those like on-device AI models, they have been applied across different industry, like from automotive, from PC, and even in some like e-commerce platform to process those transactions fast. And a small model that responds instantly and perform a specific task well can be really useful than a much larger model that is slow or expensive. So I think we should evaluate models using like a product metrics such as latency, memory, and energy use, and task completion, not just the benchmark scores. If you look at it from this level, you'll see that many small models are really useful, and we've seen hundreds or thousands of small models already running in our device.
I was poking around in your repository before we were talking, and didn't you guys have your own model at one point? What's the story there? I feel like the Nexa had did Nexa have its own model?
Yes, previously we had. Let me use two models that we developed before as an example. One of the model is called Octus V2. It's a pretty trending model that has been ranked the second place among all Hugging Face models at a certain time.
Mm-hmm.
And the idea is that small model cannot do function calling very reliably. What we do is like we propose a technique called functional token that is basically like treating each function call as a special token, like a Nexa 0, 1, 2, without any linguistic meaning, but represent some action and incorporate that into vocabulary so that small model can do reliable function calling. And we also experiment, some multimodal model for automotive. The essential idea is that we design a vision language model with very specific architecture that may not work well with good performance on GPU, but works very well on our NPU. Because our NPU, it's most of the time like a compute bound. Most of the time memory bound, so we can design the especially the vision encoder in a way that we can get even better TTFT. Yeah,
I think what you're saying about, I was really interested in what you were saying about the function calling with small models and finding ways to improve that, because like as I look at more and more things, more and more people experimenting with agentic systems, with agentic harnesses, that feels like the real hurdle that needs to be jumped over. That feels like the thing that we're trying to solve, which is how do we get small models with really reliable tool calling? Where do you think the industry is in this process, and when do you think that's going to happen?
I think firstly, like if you look at this capability like 2 or 3 years ago, like we first see it in OpenAI dev days, and at that time, language model hadn't been able to do the function calling reliably. But now I think a lot of efforts has been done in this domain. Firstly, we have more and more data. Specifically like more efforts to collect high quality data to train models so that it can do the function calling reliably. And I think this has been sort of like solved in a way. And at the same time, we see new algorithms that is developed to enforce better function calling capability. For example, there is like structured decoding, and this is a good example like how you can improve the function calling accuracy for models. And I think eventually like this is collaborative effort from the whole community. For example, there is there is like a joint effort now to help the language model to do the function calling, and that provides more data for the model to learn. And I think yeah, we are towards a very good function calling learning process for the models now.
Great. Now, another question or mention from Discord that I think gets into something interesting. This was actually something that analyst Max Weinbach commented on in a Snapdragon AMA on Reddit the other day, which is something that if you're watching this, you should go and look at that Snapdragon X2 AMA. Max is really, I feel like in terms of the analysts out there, he is the one who is most tuned in to local AI execution. He's the one who does the most work on local AI execution. So what he says matters a lot to me. From this Discord, it's a comment of someone saying, you know, he was playing with the compute units on the GGML models, and he found that on the GPU he got lower power usage per token, but it's still higher compared to the Query models. And yes, absolutely. The Query models are more efficient and they function much better on the NPU. And Max was saying in the AMA that this is because models need to be, and here's where I need you guys to explain, models need to be laid out differently to run in an optimized way on the NPU, right? Like, what is Query doing that GGML doesn't do that makes it run so well on the NPU? Do any of you guys know?
Zach, do you want to pick
Zach?
this question?
Yes, so there are a few things Quart has done. So firstly, you know, Quart is compiled offline. So it did a lot of ahead of time compilation to like for the op fusion graph optimization that Llama CP current don't have. Secondly, as we know, we are using the AI mat quant, the static quantization, while the Llama CPP right now is using dynamic quant, and also besides of that, the Quart right now is using int60 activation and can fully better leverage the HTTP's native integer multiply accumulate units, while as we know, the GGML Llama CPP using the floating point 16. So those performance advantage makes the Quart stand out.
Okay, yeah, that makes a lot of sense. There's another question coming in, which I'm not 100% sure I understand, where he says, should we start using Genie X going forward instead of Genie? And this cracks me up a little because there's so many, he doesn't know, but there's so many different things in Qualcomm called Genie. There's probably like 6 or 7 projects in Qualcomm, all of which are called Genie in some way. So I'm going to change this question to, people should use Genie X going forward instead of what? What was the previous thing that people were using that Genie X is replacing?
Yeah, I can take this one. So Genie X, we are actually the community version of Genie. So we make a lot of developer-friendly features for the community developers to try it out. So depending on your needs, you can check out both like platforms. And if you can try out Genie X when you seem necessary, and then you can try other platforms too if you seem that deems better suiting your needs.
Okay, great. Now, so we've been bouncing around talking about the compute units, talking about the compute units a lot, and I wanted to drill into that a bit more and talk about, okay, so is it that we should be running models on the NPU whenever possible, or is there any advantage? Is there a reason a developer might want to run models on the GPU or CPU? What are walk me through the different advantages of the different compute units, if there are different advantages.
Yeah, I can take it. So I think both CPU, GPU, and NPU are great, and we can talk about the NPU advantage first because that's in every device as our key strengths. So I think, in my opinion, there's three key advantages of NPU. Like first is more energy efficient And second, it allows multitasking, right, on the same device. And third, it has great pre-filling speed. And we actually did a test before when running like a chatbot using a model on a mobile phone for 10 minutes. We run it on CPU and versus on NPU. And the experience comes that NPU is much more energy efficient. And another surprising finding is that NPU doesn't throttle. So because when you run the model for a long time, on a mobile device, your phone gets hot if you're running on a CPU much faster than running on an NPU. So decoding speed actually, drops bit by bit by quite much if you run it for like 5 or 10 minutes. But so that's kind of the disadvantage of CPU. But on NPU is the temperature is nice and the decoding speed doesn't throttle, the speed doesn't throttle. So that's the energy efficiency, definitely a key advantage of NPU. And secondly, I think for multitasking, right, if you're running multiple applications, right, NPU allows you to run a language model in the background as well. So for example, you can use CPU for one task and GPU maybe for video editing, and then you run a different model on NPU. So your computer can process maybe 3 things at the same time. So that could be a key advantage of using all these chipsets at the same time. And lastly, pre-filling speed. I think the NPU pre-filling speed is very good. So if you check on the AI Hub models website, we show all the data about how models runs on NPU versus GPU versus CPU. And a lot of times, the pre-filling speed of a card model is 10 times faster than a model that's running purely on the CPU. So when we're talking about when to run each model, so if I think in general for on-device, if you can run a model on NPU, that's definitely the best because it has faster pre-filling speed and often faster speed on Qualcomm devices. And however, if you're using some like Llama CPU models that's currently not supported by card, and you can check the metrics on NPU, GPU, and CPU, and sometimes maybe GPU is faster than NPU, but we'll keep optimizing the NPU speed there.
Okay. And for people who are using other, various front ends, you guys are offering a OpenAI compatible endpoint in GenieX, right?
Yes.
So it can serve up that NPU based model to an OpenAI compatible endpoint, and then just whatever is on the other side, you could at that point you can just transition over third-party applications that I guess are used to a Llama, right? Because it's just an OpenAI compatible endpoint.
Yeah. So not just Llama. I think any cloud application, if you're using like a cloud API, you can quickly just download our CLI, do GenieX pull and GenieX serve. Then you have an OpenAI compatibility by just swapping, plug and play, so you can enjoy the local benefits of running AI fully locally. Yeah.
Now we have another question from the Discord, which is about speculative decoding, and just asking if we're going to include speculative decoding in GenieX in the future. Is that something you guys are looking at?
I can take a stab.
Okay.
Oh, go ahead, Alex.
Yeah, so that's in our pipeline. And actually, we've have some like early preview models that has been supporting speculative decoding inside Quark part. And if you search the Qualcomm AI Hub, you'll see like a Llama SSD model. That's an example of speculative decoding effort we've done.
Okay. Then we've got another question from one of the socials, which I think also I think this question actually okay. So this question shows a way that I think a lot of people and marketers need to stop thinking about AI. Okay. And this is a guy saying, and no offense, because this is the way we have trained you to think about AI. What is the model parameter limit in billions of parameters for a IQ9? And now, of course, that's entirely dependent on your quantization. So I feel like saying billions of parameters right now kind of doesn't matter, because are we talking about Q4? Are we talking about Q6? Are we talking about Q8? Like it's totally, it's different based on these other variables. But I think that the larger question of, okay, so if you have an IQ9, what sorts of LLMs should you be thinking of running on an IQ9? What is the general shape of the workload you should be running on an IQ9? Can one of you guys feel like you can take that?
Yes. So firstly, by default, GenX recommend using the Q4 4-bit quantization, both for the Llama CBP backend and for the car backend. And for IQ9 devices, we also have tested a different range of model size. And we recommend generally you pick the model size less than 4 billion parameter. So we have been running smoothly for the Q1 2.5, 08B 2B, and the Gamma E2B, Gamma 4 E2B. So those run smoothly on the IQ9. And you can also see the performance data of them on the Hub model webpage.
Okay. Okay, great. We have a really interesting set of questions from LinkedIn here. That's okay. That's okay, Deutsch. I think this answered the question for you. I was more using you as an example of, you're using your question as an example of how I want to shift the discussion to workloads rather than this one specific number. But I know, like, we all want one specific number. It's easy to understand. It makes absolute sense. And also, we were promoting this number for years. So, a question from LinkedIn. Thinking of the future with embedded AI devices that are deployed running models on device, is there an idea for devices in the field that are self-training, that can improve their capabilities and improve the capabilities of their models based on the information they're taking in? What does that ecosystem potentially look like? Or is it a matter of, you're basically just deploying a model out from a center to a bunch of distributed devices, and then they don't get any better with time? Alex, I can see you're nodding, so I think you might have some thoughts about that.
Oh, yeah. So I think this is a very interesting question. And on-device training has been a long time topic and has been got huge interest. Imagine in the future, if you have a dedicated machine, like it has your personal data, and it can serve the model for you, and it can do the training for you. So it fulfills almost all the requests that you need from AI, and ensures the privacy. So I think for now, the mainstream method is still like, you train the model on cloud and periodically update your weights locally. But doing some like fine tuning locally now is not something like impossible. We have various ways, such as like a LoRa tuning that has been already achieved. For example, in Llama CVP, which basically that capability the GenX may also have in the future.
Yeah, great, thank you. Yeah, it's a really interesting future. It's a really interesting future application of AI and way AI is going to work in the future. So if people are deciding to get started with GenieX right now, I know they can get started on their Snapdragon X or X2 laptops. They can get started, if they're Android programmers, on 8 Gen 5 or 8 Elite Gen 5. If they have a IoT kit, they can get started with an IQ9. I know there's other chipset support coming. So especially with, I'm looking forward to more official support for the large number of 6490s scattered throughout my house. I know that's coming in the future. where should people get started in terms of sample projects, in terms of knowing how this works, sample code, being able to dig into it?
Yeah, that's a great question. So for the sample code, actually, there's an open source repo. It's called AI Hub Apps. So it's from Qualcomm AI Hub. So this AI Hub Apps repository has the end-to-end reference apps for LLM, VLM, and there's a standalone example, which is a GenieX Chat Android app. So we provide both the APK and also the source code such that you can follow the code and adapt it to your own usage. Besides that, at our GenieX repo, we also provide like Jupyter Notebook for Python libraries, such that you can run it smoothly on either your IQ9 or on your Windows laptop with X Elite or X2 Elite support.
Great. Okay, so one more question from Lord Hunter on Discord, and of course, this is a question I also asked in the internal chat. So there's Quart optimized, somewhat larger, somewhat more recent versions of LLMs, like Qwen 3.5, Qwen 3.6, Gemma 4. Those are coming, right? But also it sounds like if people want to start creating those on their own, there's tools to do that, right?
Yes. So we are constantly supporting, new models. So it's definitely stay tuned to GenieX and follow Qualcomm AI Hub to see new models coming in. And yeah, people can already start contributing. If you're very interested in this, we'd love to see your contribution.
Yeah, I would love to see the community. That's the thing. Like, I would love to see the community turning more, Quart optimizing more models, more current models. If we get, especially with our new relationship with Hugging Face that was announced at our Investor Day, I think once we get that Qualcomm Hugging Face relationship really established, it's really going to take off from the developer perspective, and because the performance on these Quart optimized models is just absolutely amazing. And stay tuned for more information about that Hugging Face relationship as it develops. Hopefully, we'll do a webcast on that because I'm very excited for our integration with Hugging Face. So this is great, folks. I know people are raring to get started with GenieX. I know I'm going to be doing more with GenieX even later this afternoon. Is there anything else that I might have missed about the software that you want to make sure that people know as they're getting started? Exciting things about it that you think they should try as they're developing their applications with LLMs?
Oh, yeah, I can just want to quickly share where we can get the models. So basically, right now, in order to get started with GenieX, you can go to the Qualcomm AI Hub models to check a list of pre-compiled, optimized models through cart that you can run directly on using GenieX across different platforms. And also, with GenieX, we introduced the integration with the Hugging Face GGF models. So basically, almost nearly all GGUF models, if you just pick one on Hugging Face, or you can bring your own GGUF model, you can try to run it through GenieX across the different Qualcomm devices.
Yeah, another interesting to add here. So we actually spend a lot of time, on the documentations of GenieX. So if you have your local copy of our GenieX, you can do web coding basically very easily and reliably.
Yeah, I would say actually the documentation is really good. Qualcomm as a company, we are not known for the quality of our documentation in the past. And looking at the documentation for this project, I was like, we have taken a step up. We have leveled up in terms of documentation, and we have set a standard that hopefully all the Qualcomm documentation has to be this good going forward. This is a challenge for the rest of the company. Okay, one more question. One more question from LinkedIn. To prioritize portability across different hardware vendors or platforms, should we stick with TensorFlow Lite or Onyx Runtime, or should programmers be looking at AI Engine Direct for best performance? It's an interesting question about trade-offs, right?
I think now, from what we see, Onyx is still popular format that has been studied and also used as a standard across different hardware vendors.
Mm-hmm.
So we will recommend Onyx. Yeah. At the same time, you see, with the development of agentic coding, I think writing or supporting model using Llama 3Ps, where like basically you write everything from scratch, and it's not like a big task or a tough task anymore. You can strategically leverage AI to help you do the to port models across different hardware. Yeah.
Great, thanks. Okay, so thank you guys so much for coming onto the stream to talk about GenieX. I'm excited for it. I think a lot of our developers are going to be excited for it. And more than just being excited for this as a product, I think we are excited for it as a process, as something going forward in the open source community that is only going to get better and better with time and is really going to take advantage of these amazing NPUs, which are on Qualcomm devices and are only going to get better as we release more devices. So thanks again, guys, for coming and talking with me. Thanks to everybody who watched and will watch the replay of this stream. Once again, go to geniex.aihub.qualcomm.com for the GenieX documentation, and go to aihub.qualcomm.com to learn more about programming with GenieX and using it. And we will talk to you soon with more exciting AI developments. Thanks a lot, guys.
Thank you.
Thank you.
Thank you, everyone.
Bye.